Welcome to Study Loop.
Here we're going to look at relationships with a constant or uniform electric field between two parallel plates. So we know that the electric field is related to the gradient of the potential difference over the spacing. And that is provided that the electric field is in the x direction. There would be similar things if there were other components. We also know that the force on a particle in that electric field is its charge times the electric field. We know that work done by a force is equal to force times distance. And we also know that the change in potential energy of a particle in a potential is equal to its Q times the potential difference it experiences. So what we're after is to see how work relates to potential energy change. Okay, so hopefully it won't be too much different than what we see mechanically. But the first thing we're going to do is find the electric field between those plates using the potential difference, which is 360 volts, divided by the spacing, which is 45 millimeters. And units will turn out to be volts per meter, which is the same as newtons per coulomb. Okay, now we're going to put a positive charge near the positive plate, and it will be pushed away or attracted to the negative plate. And we're going to find the force on that charge. Okay, so we have that little charge sitting up there, 2.4 nanocoulombs times 10 to the minus 9 times the electric field, which we just found. And that should be in newtons, which will be the same as a coulomb volt per meter. But we'll just put that in newtons. And it's a small force. Okay, and we'll use that force then to calculate the work done by the field. That's an important thing. We don't have an external agent coming in and doing anything. So that's just 10 to the minus 1.92 times 10 to the minus 5 times 45 millimeters. And that should be in joules if we have used SI units. So that work is a positive quantity. And we will talk a little bit about why it's positive. But essentially it is positive because the force is acting in the same direction that the particle is displacing. And finally, we're going to find the potential energy change of that particle. So it is moving from the high potential plate and it is going down to the lower potential plate. So it's starting on the positive plate, going to the negative, which means that it is experiencing a negative voltage drop, and it is a positive charge. Should be units of joules. And what we see is that potential energy change is negative, whereas the work done by the field was positive. And that is congruent with the definition that the work done by a conservative field is minus the change in the potential energy between the particle and the field. Okay, so the work done is going to be an interactive thing. It's working on something, and that something will have its potential energy drop.